In this video I'll explain the features of the new SPIR Mk3 gas leak detector. This video is divided into sections. The screen before this introduction lists each section and the time that each section starts within the video, enabling you to skip to the information about a specific feature if you so wish. The following parts will be covered in this video: the main unit, the remote sensor, the expansion PCB and ferrite core, and the HC05 Bluetooth module. The main unit of the SPIR Mk3 incorporates a membrane LED keypad with a healthy LED, a fault/alarm LED, a reset button which can also be used to initiate a self-test, an optional local sensor, knockouts for cable entry, a product label and lid fixing screws. The new unit is actually slightly smaller than the original Mark II SPIR, and there are also slight differences with the knockouts on the unit as well. Some of the knockouts are slightly smaller, and there are also a different number of knockouts on certain faces of the sides of the unit. To mount the unit, remove the lid of the enclosure, unplug the ribbon cable, the membrane ribbon cable, and place the lid to one side. Don't leave the lid hanging from the ribbon cable connector because this can result in damage. Also, do not drill holes in the back of the enclosure for mounting the unit. Use the 4 mounting holes provided behind the fixing screw positions. The lid of the new SPIR has been redesigned to include LED graphical indicators rather than a single bicolour LED. The top indicator is the healthy status. This LED would normally be green if everything is healthy. It's actually flashing at the moment to indicate that the unit is in warm-up. If there are any faults or alarms on the unit, this LED will switch off. The LED below this is the fault/alarm indicator. This LED can actually be shown in 2 different colours, orange or red. Orange is used to indicate faults and red is used to indicate alarms. There is also the test/reset button. This is used to initiate a unit self-test, to reset latched alarms, or to mute the alarm buzzer. To initiate a self-test, just press and hold the button for a moment and the LEDs will pass through a test sequence. More information on the operation of LEDs is included in the user manual and also on the datasheet. Inside the unit we have the following features: the power input connector, the alarm relay, the fault/critical alarm relay, jumper links to set up how these 2 relays operate, the lid membrane connector, the reset input, the RS485 connection, LEDs for the RS485 data, the sensor connection, LEDs for the sensor data, an expansion board header, a Bluetooth header, a processor LED, 2 bit switches and a buzzer with a jumper link to enable and disable the buzzer. The unit can be powered from either a 24V AC or a 24V DC supply. If you wish to power the unit from a 24V DC supply and are also going to use the switch supply function to drive beacons directly from the PCB, you must ensure that the polarity of the DC supply is correct. This means that negative is this side, positive is this side. There are 2 relays on the unit, an alarm relay and a fault/critical alarm relay. The operation of this relay is defined by the setup of the bit switches over here. More information is included in the manual. Each relay can be set to operate as either a volt-free contact or to provide a switch supply output. When operating in switch supply output mode, a separate beacon board we used to have with the SPIR Mark II is not required. To set switch supply output mode, basically link the two pins on the header like this. This means that the supply voltage will actually be switched out of the relay terminals. There is also a fuse protecting this function separately from the main PCB, so if there is a problem with the wiring, the main unit should not be affected. If you want to use the volt-free contact mode, remove both of the jumper links and simply link the two middle pins on each header. There is also an LED next to each alarm relay and the fault relay, which will indicate when each relay is switched on. The relay connections are as follows. If you are operating the relay in volt-free contact mode, this is the common terminal, this is normally open, this is normally closed. If the relay is set to work in a switch supply mode, this terminal is the ground connection, this terminal would be open circuit, and this terminal would be 24 volts DC. If an alarm occurs, obviously the relay states reverse, so then for switch supply mode in particular, this remains ground, this becomes 24 volts, and this becomes open circuit. So this means that if you are wiring a beacon to the unit in switch supply mode and you hadn't set the relays up for failsafe or anything like that, so energized when in alarm, you would connect the ground of the beacon to this terminal and the 24 volt supply of the beacon to this terminal. The same order and connections of terminals applies to both relays, they're exactly the same. Next to the fault/critical alarm relay, we have the membrane connector. This is where the membrane, the lid membrane, connects to the main PCB. The connector on the actual membrane itself has a latch feature, as you can see here, which means you must press in this latch before unplugging the connector from the main PCB. As I already mentioned, you should really remove the lid of the unit before working on it. Strain on the connector can result on the connector housing actually pulling off of the main PCB. The digital input is used to connect to a remote, button or volt-free contact. When a close contact is sensed on this input, a self-test can be initiated, latched alarms can be reset, and the alarm buzzer can be muted. The operation of the digital input has not changed since the Mark II unit. The RS485 connection is next to the digital input. There are also two LEDs down here which will flash when data is received and data is transmitted over the RS485 connection. The connections are A, ground, B. This is the sensor input connector. Pin 1 is ground, pin 2 is 5 volts, pin 3 is TX data, pin 4 is RX data. There is also a new feature in that there is a TX and RX LED which will flash when data is transmitted and received from the sensor. Next we have the expansion header. This header is used for connecting the new expansion PCB which can provide the analog output and also a new Ethernet interface. This header is also where a programmer is connected to load software onto the main processor. The first 5 pins here on this side of the connector are actually used for connecting the programmer as well. The Bluetooth header here is used to connect a HC05 Bluetooth module to the unit. This module can be used to connect the device to an Android mobile phone running our Site Assistant application. To use the module, just simply plug it in here in the orientation like this. When the unit is connected, the red LED on the HC05 module will flash. Once connected to a mobile phone and working, this LED will stop flashing and will turn on steady. I'll explain a little bit more about using the Site Assistant app and how to connect to the device using the Bluetooth module later in this video. One other thing I should also mention though, that unlike the Mk3 unit, the Bluetooth interface is completely independent of the main RS485 port. So you can still use this module whilst leaving the RS485 connected to the system manager, unlike the SPIR Mark II. I should also add that the Bluetooth module is not intended to be permanently left connected into the unit. It is really only there for commissioning and for maintenance of the unit. Once you have finished using it, you should always unplug the HC05 module. Here we have the processor LED. This LED normally flashes to indicate that the processor is running. This LED is also used as part of the factory reset process. I'll explain this a little bit more later on in this video. There are two bit switches which are used to configure the unit. The operation of these bit switches and the parameters that they configure has not changed since the Mark II unit. Bit switch set 1. Switches 1 and 2 set the alarm delay. The actual alarm delay used will depend on the kind of sensor connected to the unit. This is all explained in the manual and on the datasheet. Switches 3 and 4 set the alarm delay. Switch 5 sets if the alarm relay latches. Switch 6 sets whether the fault/critical alarm relay latches. Switch 7 inverts the state of the alarm relay or sets it failsafe, and switch 8 inverts the critical/fault alarm relay or again sets it failsafe. On the second set of switches, switches 1 to 5 set the RS485 network address. Switches 6 and 7 set the operating mode, and the last switch, switch 8, is used for performing a factory reset. Finally, we have the alarm buzzer, a much smaller buzzer than on the Mark II unit, but will also provide a similar decibel level. There is a jumper link next to it here which can be used to permanently disable or enable the alarm buzzer. The expansion PCB provides the additional functions of an analog output and also an Ethernet interface. The expansion PCB will be supplied in a kit including the PCB, some mounting pillars, and if the expansion PCB has the Ethernet interface, there will also be supplied a ferrite ring. The expansion PCB will be supplied in 3 different formats: a version with only the analog output, a version with only the Ethernet output, and a version like this one here which has both the analog output and the Ethernet output. On the PCB, this is the Ethernet connector, this is the programming header, this is the jumper link for selecting the operation of the analog output, and this is the analog output terminals. To mount the expansion module, clip the pillars into the PCB. There's actually one missing on this example here, but clip the 3 pillars onto the PCB. Carefully align the PCB over the pillars and the header. First of all, make sure you've switched off the unit, of course, and then just press it down. This now holds it in place. Then repower up the unit. The analog output can be configured to provide either a 0 to 20 milliamp signal, a 0 to 5 volt signal, or a 0 to 10 volt signal. This is done by moving the jumper link across these pins. In this position here, the output will operate as a 0 to 20 milliamp signal. If we move it over to these two pins here, it will operate as a 0 to 5 volt signal, and if we move it over to these two pins here, it will operate as a 0 to 10 volt signal. The connections onto the main connector terminal are ground and signal. If the expansion PCB has been supplied with the Ethernet interface, there will be a separate processor LED on the PCB which will flash to indicate that the processor running the Ethernet interface is running correctly. The kit will also be supplied with a ferrite ring which must be clamped around the incoming Ethernet cable to ensure that the EMC standard we have applied is adhered to. There are also on the Ethernet connector itself link LEDs and activity LEDs. One other thing to note is that the Ethernet interface actually retrieves data from the main PCB via the RS-485 interface. This means that you cannot use the RS-485 interface if the Ethernet interface has been fitted. At the end of this section I will display a screenshot of the Ethernet interface showing the web page that it provides. As well as this, the interface will also provide Modbus TCP/IP and access to all of the same registers which would normally be available via the RS-485 port. Here we have the remote sensor for the SPIR. This is very similar to the Mark II SPIR remote sensor. There really are very few changes in its design. Obviously a different enclosure and a different label on the front. The PCB inside has been changed very slightly. So the old one had screw terminals for the sensor and the incoming connection. The new one has a plug and socket connector, which means that the sensor can actually be removed from the box without removing the box from the wall, and enables you to pass the connector through that hole and then install the new one through the same hole without having to unwire all of the terminals. As with the main unit, mounting of the sensor should be done through the holes behind the lid fixing screws. Do not drill any more holes on the enclosure. This is very important on the remote sensor for the IP rating because of the location in the environments where these are normally installed. There is also a gland provided on the unit for the incoming cable which goes back to the main unit. Make sure that the rubber grommets are left in place. So there's a rubber grommet here and there's actually a rubber grommet in here. The terminal connections are ground, VCC, TX data and RX data, so black, red, green, white. The factory reset process for the SPI Mark III has changed very slightly from the factory reset process on the SPI Mark I. We now have two levels of factory reset. So a level 1 factory reset will reinitiate all of the alarm settings and alarm delays to the factory default, and a level 2 factory reset will reset all of the IP address settings for the Ethernet interface to the factory default settings. To perform a level 1 factory reset, switch bit switch 8 on set number 2 on, and as you can see the processor LED now switches on steady. Next, press and hold the reset button for 10 seconds. As you can see now, the processor LED is flashing fast. This indicates that the level 1 factory reset has been completed. The unit will now remain in factory reset mode, and if you wish to now reset the IP address settings or carry out a level 2 factory reset, you would simply press the reset button again momentarily and observe the state of the LED. And as you can see, now the LED is flashing very briefly. This indicates that the unit is now ready to do a level 2 factory reset. To perform a level 2 factory reset now, just press and hold the reset button for 10 seconds. And as you can see now, the LED is flashing fast again. This indicates that the factory reset has been done. Once you have finished, remember to turn off bit switch A on set number 2. And the LED returns to flashing at a 1 second rate. Also note that during the time that the factory reset LED was switched on, you may not be able to see it in this light, but the actual healthy LED will actually turn off as well. If you wanted to only perform and go straight to doing a a level 2 factory reset, switch on the switch number 8 on set number 2. The LED goes steady to show that it's in factory reset mode. Press momentarily the reset button until the LED changes to the flashing rate for a level 2 factory reset. Press and hold for 10 seconds. And the LED flashes fast to show that the factory reset has been completed. Finally, I'll show you how to use the Android Site Assistant app via the Bluetooth HC05 module. So first of all, obviously make sure the Bluetooth module is connected to the unit. Shown in the orientation shown here, you can see that the red status LED on the module is currently flashing. Next, start the app on your mobile device. Go to Settings, go to Bluetooth Settings. Your device should now scan for Bluetooth devices, and as you can see, the HC05 module has appeared down the bottom. Click on this and it asks you to pair. The code would always be 1, 2, 3, 4. Click pair, and it's now paired with your phone. So now go back to the Site Assistant app, click on the paired device and select HC05, click OK and click Save. Now at this point it's ready to go, but we often find that sometimes you may get an error if you try to connect straight away. It's best to now quit the Android Site Assistant app and come back in before you try and connect. So that's what I will do. Reload the app, and now it should be ready to connect. So just press the play button, or the scan button rather. Bluetooth opened, and it's now scanning for devices. And as you can see now, it's found the Bluetooth device. So the address, if you're using the Bluetooth adapter, the address will always be address number 1, because it uses a separate interface than the RS485 port. It totally disregards the RS485 network address, so the Bluetooth device will always respond at address number 1. As you can see here now, the LED on the HC05 module is now not flashing at a fast rate, it's flashing at a different rate. This is indicating that the connection has now been made. On the screen here, to give you a quick run through of the app, this is the overview screen. showing you the concentration and the gas type. If you just click on number 1 there, it brings up the status page for that unit, showing a live graph, the sensor full scale and the alarm and fault status. We have the settings page where you can see the alarm settings. Obviously, part of the feature of this is that anything shown in green you can change, anything shown in blue you cannot change. And so because we've selected alarm thresholds on the bit switches here, it means we can't change them via the app. We also have the IP address settings down here. If the Ethernet expansion board wasn't installed, or if the Ethernet expansion board didn't have the Ethernet feature, this would disappear. We can also initiate a self-test, obviously. There's additional information for the unit, so the serial numbers, the sensor, build date, software versions. We can also read and write any other register, Modbus register from the device. There's also a calibration page where you can recalibrate the sensor, and there's also the option to generate a commissioning report. That concludes this video introducing the new SPIR Mk3 gas leak detector. Whilst I can't expect everyone to have found it interesting, I hope that it has given you some information that might be useful to you in the future. Bye!